Welcome user. In the previous video we have completed theoretical part of k-means clustering. In this video we are going to implement k-means clustering in the MATLAB. So let us begin. Under workspace window I have already imported data for analysis. First let us check the data and we will note some points from data. First point, we can note data contained 25 observations and 7 features. This is clustering problem, so we don't divide data into output labels and input features. In clustering, we do grouping of data based on their similar properties. Second point, we can note data have both numerical and categorical features. But from categorical feature, we can neglect university feature as it is not going to help us to do grouping. Remaining numerical features we can consider for analysis, and we can make k-means model by considering remaining numerical features. But for simplicity, I am going to only consider two features for analysis. So I will make model based only on two features, and I am going to choose expenses and graded features for analysis. Now let us see MATLAB code. Right here I have just saved my data into raw data variable. So now I can do operations on raw data variable, but data from universities variable is not going to change. In the next step of code, I have removed 1 to 5 columns from raw data variable because I am going to only consider the last two features for analysis. After that, the next steps are exploratory data analysis, handling missing values and handling outliers from data. Assume I have done all these steps. And if I look data, I found that both features are needed to be scaled, as both features have different range and different units. Both features are continuous numerical, so I have applied standardization on the two selected features. If we check scatter diagram, then we can see we can make two groups based on the selected two features. Now the next step is to calculate optimal k value, and optimal k value we will decide by looking into elbow plot. In elbow plot, number of clusters lies on x-axis and sum of squared error lies on y-axis. In the code, first I have created empty WCSS variable that will store sum of squared error for the mentioned cluster. I have mentioned clusters from 1 to 6. It's our choice to mention range, as we guessed by looking into scatter diagram that we can make two clusters, so I ended with 6 value. In the code, IDX will store cluster value, C will store centroids value of the clusters, and S will store sum of squared error. K-mean is the function that will perform clustering. In function, I have passed three arguments. The first argument specifies the data I am going to consider for clustering. Second argument will specify number of clusters, and third argument will specify start method. There are so many start methods, but plus would be the optimal one. And if you want more information about the start method, you can refer documentation of k-means function. The last line of code will append all sum of squared values with respect to number of clusters. If we plot cluster versus sum of squared error graph, you can see elbow at 2. So we can conclude for this dataset optimal number of clusters are 2. So I will select k is equal to 2 and I will run model. You can see unique values from IDX variable, and we have grouped the two features into two groups. Let us visualize the data. Gscatter function would give the same visualization like scatter, but in gscatter we can see data based on clusters that we have stored in IDX variables. If I run the code, you can see data is divided into two clusters. To get centroids of two clusters, type C in command window. Also, we can store this grouping information into the original data. If I run the code, universities table would be updated with new clusters feature. Now check the universities table. You can see new feature, name is cluster, and we have divided the data into two groups. The first group belongs to cluster 1 and second group belongs to cluster 2. And we have done clustering by considering only two features. We can export updated files by using write table or by using CSV write function to the selected working directory. We can also make model by considering all numerical features. At the end, I would like to add limitation of k-means clustering algorithms. K-means clustering algorithm suits for spherical or circular type of data distribution. Algorithm does not suit for spiral and U-shaped type of distribution. Also, it will group correctly when data is denser. This will end our video. In this video, we have seen MATLAB implementation of k-means clustering algorithm. In the next video, we are going to see next algorithm of clustering. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our future. Happy MATLABing.